morning. I hope you are preparing your examination, and I know this is a very once again tricky time because about few days still to be there for your examination, and where you can stretch utmostly to just get some promising and good marks. At the meantime, if you are thinking, let's say some ABC chapters for some unit or some topic where you got confused very much, so kindly suggest me. I'll surely make some video to help your cause. Fine. So today I have taken very interesting session, and let's say this is a topic it was already asked in your examination. So let's cover the basic theory and then we will see the numerical that is based on it. So in this section, let's take, we have seen once the body is on a straight line motion here, and if force is applied, the body is supposed to be moving in the direction of force. So here you can see the direction of force, and this once again yesterday I told you 1D motion, and in 1D motion it has only one acceleration, that is linear acceleration along the given force direction. Fine. Let's say I am denoting by IL, linear direction, the direction of force. The, now what exactly happened in 2D motion, you have seen a specific case of it, that is circular motion. It has a two type of motion that you frequently see, that is called as a centripetal, or we can also call as a radial, because it is acting along the center of this curve, this special curve that is circle only. But any general motion if you are talking about, so general motion is curvical motion, and circle is one of the specific case, and one more acting that is along the circumference that I have denoted by AT. That is the example of 2D motion. So here the acceleration will be the a radial, let's denoting by some unit vector, plus at unit vector. So these are the two acceleration acting depending upon the motion. Now let me tell you more general case. So the more general case is, let's say this is curvical motion. I repeat, in your examination, circular motion and projectile is one of the specific case of 2D motion. So what exactly happened if I'm taking some reference? Clear? If I have taken some reference, and from that reference point, let's take, I have taken this point. Clear? And this point having velocity, let's say in a tangential, this is the direction of velocity. Let's say this is point A and this is point B. Now here we can say uh, radius is not changing. Here, radius is not changing. This AC is for the sake of velocity change. Always remember, because radial acceleration it will be appear once the direction change and radius change. Now here we can say this is very general example where the radius means from the center of that reference point. This is a reference point actually. If I'm taking this reference point, and if I will mark these 2 points, so you can say this is radially also changing. Fine, radially also changing. And if you can see the angle, so this is angular position actually. You can say the body is changing its location linearly, point A to point B linearly change with respect to O. And here you can see, let's say this is d theta, and angularly by these two way the body has changing its location. So for the sake of specifically if we can divide the velocity, so we can say the velocity get divided into two components. Let's say this is v, so this component we can call as vt, v, or let's say v radial, vr, that is v radial means along the center, whatever the virtual center we have considered, and one value that's perpendicular to it, that is v angular, means the total velocity get divided into two sections, v radial, v angular. We can also call this polar component. Polar, like you have seen Cartesian. Cartesian means one side divided in x and y perpendicular axis, that is called Cartesian. Means if you have taken any vector, if you have divided along x-axis, so you are writing like v cos theta and v sin theta. That is Cartesian way I am dividing velocity. Clear? But we can also divide, this is called x comma y form, and this particular form is called r comma theta form. R means radius change and theta will change. So this coordinate is respectively called Cartesian coordinate and polar coordinates. So here 2D motion or circular motion we are studying in terms of VR and V theta. Basically VR and V theta means R cos theta, R sin theta, that is equivalent to x comma y, means x is r sin theta, y is, so we can respectively change the polar coordinate into Cartesian coordinate. Once we square and add, so basically we get r square is equal to x square plus y square. So here we can get the value of r in terms of x and y, and once we divide, so we can see tan theta is equal to y by x. So by this way we can easily convert Cartesian into polar and polar into Cartesian. So here we can convert polar into Cartesian. Now what exactly happened here, since theta means angular position is also changing, and the angular position is changing for the sake of its magnitude. Always remember magnitude and direction both, because in circular motion what you have seen AC is we can say radial acceleration is changing for the sake of magnitude in circular motion. Please remember, not for magnitude, because magnitude v square by r, if you are talking about, if uniform circular motion is there, velocity that will remain same. So at any point if you are looking for radial acceleration, to you might be keeping v square by r. So here v square by r, the magnitude is not changing, but for the sake of direction changing, the radial acceleration is changing. But here in the given case we can say the magnitude and the distance both will be changing. That's why v theta and vr, the two component, that if it will change, so respectively if the velocity will change to, and how we express v theta, so here I'm expressing v theta, that is equal to, like you have seen r d theta, because arc is there, the velocity is equal to distance by distance is r d theta, angular distance divided by time, so r d theta by dt, and vr is equal to, basically r is changing, that's why distance by time. So this is a v theta and vr velocities magnitude. Now once you further differentiate it, so this is important here. Now once you once again differentiate, so v d theta by dt, that is acceleration, and acceleration is equal to, we will use a dot product rule, first function into differentiation of second function plus second function into differentiation of first function. Fine, because both is variable, that's why both term will be appear. But what will happen in the case of dr by dt, we can say only r one component, so double differentiation, that will give you ar. By this way we can calculate the radial acceleration. Clear? So I thought this discussion, let me sum up quickly. So here what we can say in, now one more thing I would like to stretch your attention on. Ki this is a velocity, and velocity always, let's say this is a velocity vector and this is acceleration vector. Clear? If I would like to draw the next situation, so always remember which vector will move towards next vector, acceleration towards velocity vector, velocity toward acceleration vector. So we can say next situation most probably acceleration, and let's say this angle is theta is equal to, let's say, 15 degree. Clear? So next time angle will further decrease. Let's say this will be 12 degree. What exactly happened? Velocity vector shifting towards acceleration vector. Velocity is changing its direction according to acceleration vector if this is fixed. Though the rate of change of velocity is acceleration, but my point is, if velocity will always follow acceleration vector, velocity always follow acceleration vector. So here we can say, if this is the situation, so let's say this is velocity vector. Once again, we will make the velocity vector into two component. If I'm making the some coordinate, let's say this is the radial component, and yes, let's say this is the direction of velocity. Next time velocity will go like that. So let's say this is v1 and this is v2. So you can roughly guess, like if I'll change the, is it v2 minus v1, if you need to calculate v2 minus v1, so v2 vector will remain as it is. This is the direction of v2 vector, but v1 vector we have to flip the direction. So this is the, we have to flip the direction, that is minus v1. And once we change, so this is the direction, this is delta v direction basically. Fine, this is the delta v direction. So you can roughly guess the what is the direction of acceleration. So acceleration direction, of course, it will be towards the curvature. This is a curvature we can say. So acceleration direction, of course, towards the inward to the curvature. Like here the curvature is, so of course acceleration vector will be in the curvatures into the curvature. So we can roughly sketch the acceleration direction. And here my point is, if we have considered this axis as a reference, so this velocity have a two component. One is a radial, and next is, in fact, this is v theta. Fine. And the next component is, that is called as radial. Uh, Fine. So let's make the velocity bit upright so I can able to show you properly. Radial means any vector that is passing through that center. This is the radial direction. Clear? So let's do the question that is based on it. Now kindly read the question properly. Here it is mentioned, let the r is the distance of a particle from the fixed point. Fixed point means, once again the situation is, let's say the same situation. This is a fixed point which is attracted by the inverse square law. Inverse square law that the Coulomb's law, gravitation law, all are inverse square law. This is the basic expression of it. If m is the mass of a particle, fine, and L is the angular momentum. Now they have given uh, so let's take this is a mass particle that is situated at a distance r. Clear? And of course, the second particle should be at the origin only. Only get properly the language of the question. So let r be the distance of a particle from the fixed point. This is a fixed point to which it is attracted by inverse square law. So of course there should be some masses are there. Let's say m1 and m2. Force given by and whatever the force it is there, that is given by inverse square law. And as you know, mass, let the mass of the particle is and L is the angular momentum with respect to fixed point. Fine. Maybe it has some curve path. Here we can say if it's attracting in the given path, it will come like this. So once again, it will perform 2D motion, and 2D motion has a two type of velocity v theta and vr. Yeah. Angular momentum is it will moving in a curvical path, or the specifically we can call as like circle is one of the example of 2D motion, but here they are saying in angular means it will surely a part of some curvical motion with respect to the fixed point, with respect to fixed point. Now which of the following formula is correct about the total energy? Now once again, any particle if the conservative force is there, fine, if conservative and energy, so we can say total energy will be the sum of total energy will be the sum of kinetic energy plus potential energy. And as you know, potential energy, negative of potential is equal to work done. How connected these things are, maybe you can observe. And if you remember, you have seen if we can write W, like here it is variable, so we can say F dot dr. So basically, F F dot dr. Now here in the given question, F it is given in function of R. So once we integrate it, to what we will get? Potential energy. So look, potential energy we can directly get by using this set of equations. So maybe in your examination the question will come total energy. Always remember conservative force is there, so it will be the sum of kinetic and potential energy will be further equal to negative potential is equal to work done. So basically you can link the work and get the potential energy. So this is the first energy that we can recover very easily. Now what about kinetic energy? So once again I told you since it is a 2D motion, so there is a two type of kinetic energy associated with it. One for the sake of radial velocity, another for the sake of in fact angular velocity and radial velocity. Now many students they committed mistake, they will only looking for one type of velocity because here the particle will executing some curvical motion. So we can say v theta and vr, there's a two type of kinetic energy associated with it. This is important. Fine. So let's see the option first. Option one, how many terms are there? Now if this concept is clear to you, you can say there should be three. Here you can see how many terms for kinetic energy, two terms, and potential energy, one term. So there should be total three terms. So one, two, three. One, two. This is incorrect. Now one, two, three. This may be and none of these. So I thought the option will be from option one and option three. Clear? So let's quickly analyze. Now let me tell you. Now here. Now here you can say F, it is given the earlier step I told you how to calculate potential energy. So please remember this formula. Maybe it will come in your examination. Delta U is equal to minus F dot dr. Means delta U is equal to negative of work done. So this formula is, it was already asked in first attempt, second attempt, once again asked. So you better to remember this flow of the equations. Now once we get, now F dot dr, once we have calculated, we have received this term. And I thought this is there in option as well. Now once again, if you are talking about the kinetic energy, the kinetic energy has a two part actually. One is theta and one is radial. Clear? So what we can say, basically radial is dr over dt that we have seen in the given formula. So kinetic energy, the basic formula is half mv square. So basically m, and what about v? V is dr by dt. So this is dr by dt whole square. Clear? Now, now the next important statement they have given, some angular momentum they have given. And as you know, the basic formula of angular momentum is angular momentum mvr, or we can say I omega is also a form of it. Basically angular momentum is linear momentum multiplied by perpendicular distance. Fine, linear momentum multiplied by perpendicular distance, that is called as angular momentum. So in terms of inertia, I omega. So basically L they have given. To by L, the basic clue is you can get the V actually. Once we get the V, so we can say the formula of tangential that you are talking about, that is half mv. V, now value of V we can substitute by using this angular momentum equation. So ultimately what we can say, that I told you the total energy, it will be the half m, this is a radial, and this is the tangential. Tangential, once again velocity is half mv square. Once you are keeping V by using angular momentum, angular momentum. Fine, that velocity once you are keeping, you will discover the second term, and this is the potential energy. So by this way we can get the answer of this question. Fine. So video, kindly just go and see in 2x speed, so you can able to get what is the basic of this question. And basically if you are doing conservation of energy, so please remember kinetic energy and potential energy. Potential energy we can get by the chain of minus w, and w is equal to, if it is constant or if variable, it is f dot dr. Constant, so f into dr. Potential energy get by this chain, and kinetic energy if it is having 2D motion, so we can say radial and tangential, two type of velocity it will going to exist. That's why in total we can say this, by this way you can do this question. And let's take few more question, because let's 5 minutes we will spend, because otherwise video become very large. uh, let's talk about quickly another concept that may be utilized. Now this is the question. Okay, let's discuss this question in the next video. Fine. So till then, take care and keep studying. I will help you out at mostly whatever I can.